Hi, everyone. Welcome to the Empowerment with Power BI webinar. For those of you that were in the webinar last week, welcome back. And for those of you just joining us for the first time, welcome. We're really excited to share a lot of interesting information with you. We're going to give people a few more minutes to join. So go ahead and relax and we'll get started in a couple of minutes. All right, everyone, we're going to go ahead and get started. My name is Sarah Weeder. I am a marketing associate with Motifworks, and I'm going to be sort of moderating the webinar today, helping you with any questions or anything that you may have. This is part of the Empowerment with Power BI webinar series, and we are really excited to share a lot of valuable information. Tarun Agarwal, the Director of Data and AI at Motiveworks, is going to be leading this webinar today. He's very knowledgeable and expert in the field, so we're very excited. Tarun, I'm going to let you go ahead and take it from here.
All right, thank you, Sarah. Really appreciate it. Hello, everyone. Like Sarah mentioned, my name is Tarun Agarwal. I'm the Director of Data and AI Practice at Motiveworks. So we are going through a series of webinar on Power BI and how can we use Power BI to really enable data culture in organization and empower employees to really start using data for their decision making. So this is the second webinar in the series of this Power BI webinar. Little bit background about myself, just in a brief. Like I mentioned, I'm the Director of Data and AI Practice at Motiveworks. And I have about 20 years of experience working and delivering various data-driven solutions in large organizations, mostly focused around financial services. And at Motiveworks, we are helping our customers to enable digital transformation in their organization by leveraging Microsoft Azure Data Platform, services, cognitive services, machine learning, artificial intelligence, those kind of things. And Power BI plays a very important role in uplifting the data capabilities and really enabling the data culture. So a little bit background about Motiveworks, just very briefly. We are about 10-year-old company. We are a company which is born in cloud, and we live and breathe cloud. And we are very outcome oriented. We actually help work with our business customers to deliver business value, which is depending on the different kind of use case, whether it is accelerating their digital transformation or building intelligent applications, leveraging various data and AI services, or modernizing their infrastructure or application innovation, those kind of things. We work in a breadth of Azure services, whether it is related to elevating their client infrastructure to cloud and rehosting their data centers and applications in cloud, or going through the various forms of application modernization using cloud native services, or data modernization of using cloud scale analytics. We help them innovate their applications and product and services. And we also help them manage their cloud services and do manage services and operate their cloud. We are Microsoft Gold partners, and we have all the right credentials that is needed to deliver the services on the cloud platform. So this is, like I mentioned, this is the second webinar in the series of 5 webinars around Power BI. Last exactly a week from today, we actually talked about how can we replace Microsoft Excel-based reporting using various features in Power BI and really enable end user BI capabilities, and then move people away from the traditional VLOOKUP, pivot table, those kind of reporting using Power BI solution. Today, we are going to take the knowledge that we have learned in the last webinar, a little bit, and extend it a little bit further. And now we are going to talk about how do we really ingest and consolidate and really shape the data. And by shaping the data, I really mean how can we create the right data model which is required for fast performing Power BI reporting. And then you will be briefly touched upon some of the features of Power BI Query Builder using the M query. Today, we are going to extend that learnings that we did last time to really understand more features and capabilities of M query in the Query Builder. Okay, and then we will be able to, using all these learnings, we will be able to demonstrate how do we consolidate and transform the data and create it that is ready for reporting. All right. But before we jump into the material of today's webinar and learn more about data shaping and data modeling, let's go through a understanding of where you are in your data journey in your organization. Do you currently use warehouse or not? So you will see a poll coming up on your screen. Please take few moments to let us share with us and let us know that do you currently use a data warehouse for reporting in your organization? And if you do, whether it is an enterprise data warehouse or a line of business data mart, or kind of a solution. Yeah, I think various companies and organizations use their data differently. Some companies build data warehouses. Some people build various other flavors of data consolidated repositories. Some people directly go against the transactional or production application databases. So let's try to understand. So, Sarah, you see the answer responses trickling in?
Yeah, it looks like just about everyone has voted. So what I'm seeing is 56% are saying yes, they do have enterprise data warehouse. 22% have transactional database as a source, and 22% use Excel and other files.
Okay, that's great to hear. So the 56% who are currently using enterprise data warehouse, I'm assuming that their data warehouse is using one of the standards of data warehousing, like a star schema or Snowflake schema or some kind of a schema they are following. But the other remaining 50% of people who are using some kind of transactional database or using Excel file or some other file as sources, think they will get able to understand what the importance of data model is and how are we gonna how we create data models in Power BI to really get the same kind of experience that in Power BI that otherwise companies get through an enterprise data warehouse kind of a solution. So quickly a refresher about Power BI. I think we covered this last week, but I'm just gonna refresh everybody's memory by spending a few minutes on it. Power BI allows you to experience your data. Any data that's coming, whether it is coming from, I think in just example we talked about, whether it is coming from enterprise data warehouse or transactional database or files, it is originating in cloud or on premises, whether it is a structured, unstructured, or any kind of data that you have, you will be able to bring it in Power BI and experience with your data. When I say experience with data, is basically able to drive data insights and use it for decision making. And you can consume this data anywhere you want, whether you want to see the reports and dashboards on a browser or on a mobile or inside Microsoft Excel, or embed the reports in any other applications that you have built, or even directly see in other shapes or form. It allows you to consume the data anywhere you want it to be. We also talked about last time, if you guys remember, there are different life cycles of BI, and I think right now we are in the third wave of BI, which is really end user BI. So end users need the data at their fingertips whenever they want to use it, right? So they want, what are some of the main needs that end users have, and how does Power BI fulfills them is what I think we are talking about here. So end users want the capability to access the data, any data that they want, whether it is coming from whatever sources. Then not the data, not what comes, it's not always clean and perfect. So they want ability to for them to clean the data, combine the data, create data mashups so that they can really generate meaningful insights from it, explore the data, visualize the data so they can create the right storytelling using the data. And then once they come up with some kind of a data insight or story around the data information that they have, they would like to share and collaborate with their colleagues or other people in the organization. And Power BI enables all of those things. Power BI has around 115 plus data sources that you can use to connect to your source systems. Again, just to talk about briefly, whether it is coming from some cloud sources, there are several native cloud data connectors like Salesforce or Google Analytics kind of data connectors available for users to directly consume the data from the cloud sources, or organizational data sources, whether it is relational database like SQL Server, Oracle, DB2, Sybase, you name it, or even uh, MPP kind of data sources like Netezza, Exadata, those kind of data sources. It allows you to connect and consume directly, or data generating from file systems, right? Has really a comprehensive package for data connections. It allows you to clean the data and join the data, combine the data, massage the data, and we saw some features of these capabilities last week. We are going to see more of that today, and how can we really clean and combine the data. And then once you clean and combine the data, it allows you to explore the data, create really good, compelling stories around your data that you can share with your colleagues and other people in the organization. So with that knowledge that we have acquired last week, let's quickly talk about, when we talk about how do we shape the data or how we combine and consolidate the data, what do we really mean by that? But what we exactly we are talking about is creating a data model that really can support the reporting that you would like to do, right? Analysis that you would like to do. So why is data model important? Data model actually is a combination of homogeneous structures. So like in this example, what I'm showing is a sales table will have all the sales related information. Then you have tables like calendar table or a date table. You have all your dates and date rows into month and month into quarter and year and so on and so forth. Or you have a product table that has various product attributes, a customer table. The purpose of this is it is a homogeneous structure. You have a specific purpose of each of these tables, and inside each of these tables you have different columns. So each column has a defined data type that allows you to store certain data, whether it is a character data or integer data. Each of them is defined. So this is very unlike than Excel file, where you can store pretty much any data in any cell in Excel, right? So that is not really very meaningful when you start doing some reporting and advanced analysis. You really need to understand your data model, and this becomes like really a foundation of defining a data model. When you look at the data model at a very high level, the way we define the data model that is suited for reporting is you have a set of tables, which is called fact table, which is where you contains all the measures, or measures is actually all your business metrics that you would like to report on. For example, revenue, sales, cost, number of units, those kind of things. And these measures are actually across various other attributes of that of your business domain, which is really called as dimension tables. So in this screenshot image, you can see we have different dimensions like customer dimension, product dimension, campaign dimension, and so on and so forth. Each of these dimensions contain the attributes around the product of your company or customers of your company, and so on and so forth. And these tables are joined through what we call as relationships, which is define how this data can be accessed when we try to do any kind of query or reporting around it. So there can be multiple types of relationships. Standard one is called one-to-one relationship, which is like for an employee table and an employee address table. So one employee has one address, so on and so forth. Or one-to-many, like you have a department table and you have employee table. So one department will have many employees, those kind of things. Or it can be a many solution, like many records have multiple records in the other table that you're trying to define. So the fact table, the dimension table, and relationship between this table, that's really define the core heart of a data model that is used for reporting. So there are different types of data model that you can create, and I think some of the over 56% people answered that they have some kind of enterprise data warehouse that they are using. So I'm sure they are familiar with their data model, which is defined. Typically, there are three kinds of data models, and it is not only three. These are the most common flavors of data model types, which are used for reporting and analysis purposes. The first one is a flat or a denormalized structure, which everything is in very in one table, maybe a large chronological kind of a table structure. Other one is a star schema, and third one is called Snowflake schema. And we are going to briefly look at all three of them quickly. The flat or a denormalized schema actually has pretty much all the columns that you need in one table, let's say. So if you can read through, I apologize if the screenshot is a little smaller, but if you can read through it, this is a kind of a sales table, which is actually showing you all the products that are sold, but then product ID is there, but then the product's name is there, and every single record, the product name keeps on repeating, and so on and so forth. You see, you have customers and the customer name and address, and all of those things are reporting. So this is called a flat or denormalized schema, where every single data element you need is actually part of the same structure or same table. So this actually is gonna really expand the size of this table, because you are repeating the values which you are storing, like product name, the customer name, first name, last name, email address. They will repeat for every single row for sales or transaction you have in this table. So it's good that it does not have a lot of joins, but this table size is going to expand very quickly depending on number of rows you have. So another flavor of the same data is called star schema, where actually what star schema really is, there is a central hub, and then there are spokes around it. So your fact table, which really contains and store all your measures and metrics, it's actually at the center, and it connects to all the dimension table using relationships. So here you can see the sales table, which is a fact table, has product ID, customer ID, and campaign ID, or the date also is a kind of a key. It is actually joined to each of them is a dimension table around this sales table, and allows you to store only the IDs in the fact table, but the product names and everything is stored in the product table. So you only in the product table you only have one record for one product ID. So your product ID, product name is only going to repeat once. So from a size of the database and the size of the table perspective, this is much more optimized way of storing. But the negative downside of that is every time you are trying to query sales table and you want to see the product name, now you have to join the product to the product table to get the product name, right? So that's the concept of a star schema model. Power BI really favors star schema model. Power BI is not a very good tool to use flat or denormalized structures, and the reason for that is Power BI is an in-memory solution. So every time you bring in the data, it's actually storing the data and caching the data in memory of the Power BI tool. And even though it is using a Vertipack compression engine, but you can imagine that if the tables are structured in a star schema in a normalized fashion where you only store the product names or customer name once, the size of each of this table is going to be less, smaller than the size of a denormalized table, which gives a very good memory consumption efficiency of Power BI, and it performs better. There's another flavor of a star schema, which is called Snowflake Schema. The concept remains the same as the center, say, fact table and surrounding to it are the dimension table. But then you see another component called a snowflake. So here you can see a customer dimension also has a zip code. So it's possible that multiple customers live in same zip code. So if you are going to not create a snowflake, the zip code information will repeat for every single customer who lives in the same zip code, right? So to normalize this also, we can create a separate geography table where zip code is the primary key or the unique identifier. So it only has one zip for each row in the geography table. So that way you can further optimize the consumption of the memory using a snowflake kind of a schema, which is extension of a star schema. All right, so we will also talk about the granularity, and depending on what kind of data you are dealing with, the granularity or the lowest level grain of the data could be different. So in this example, what I'm showing you is a sales table, which is, you can see, is at the date level and the product ID and a customer ID. So the actual data for the sales is for each product and for each customer for each day, right? For each campaign, it's saying how many units were sold. But if you look at the budget table is at a very different grain. It's not at the date level, it's at the budget month level. So it's a monthly budget. It's not budgeted every day level budgets. And you can see it's not at a product level. It's at the category and segment level. And if you pay attention to the product dimension does not have a category and segment, but product dimension is linked to another flake here called category segment dimension, which has the category and segment. So your sales information is at a lower level grain at the product ID level and the date level, versus budget is at a higher level grain at a month level and a category and segment level. So so these are the different granularity and in depending on what fact table you are dealing with. And we are going to see now in practical, how do we create a structure like this in Power BI that can enable your reporting across sales and budgets. All right. So with that, let me jump into Power BI. And before we jump to the Power BI, let's review the data a little bit so we understand what kind of data we are dealing with. So this is my data that I'm getting for all the sales information. As you can see that I have all the data at the product ID level for each date, each customer and campaign and units, the data model we just saw, right? Then I have also all the dimensional data, the reference data. This is geography data for each zip code. It tells us which city and state it belongs to. We have a product data that tells me a product ID, what is the product name, and it also has the category and segment data, right? And also has the unit price and the unit cost of the data. But you can see each product and which category and segment is part of the same data information that I have on the product. Customer has a customer ID and the customer zip code, which zip it belongs to, so we can see the zip code. We can get the city, state, and country from zip code from the using the customer data. Campaign data has around the campaign ID and which what kind of campaign it was run on, and then we have the calendar table, the date table. So that's my data that I have around my fact, sales dimension, sales fact, and all the surrounding dimension. I also have a budget data that shows me all the budget that was defined at the before the beginning of the year by the various business leaders, and it also gives the forecast done by the business leaders as the year starts to progress. So it has the forecast data, and it also has a budget data, right? And then the data is at the month level. You can see each month has the forecast data, like month and year, and you also have each month and year budget data. And then it is at the each category and segment levels. Like I was mentioning that this data is not at the product ID level, it is the segment and category level. So we have to see how can we create a data model using this kind of structure. And as you can imagine, this is like a cross table defined, which has data sitting in columns for various category and segments. So it will be very interesting to see how can we consolidate, transform, and shape the data in a data model. We just saw it here, right? Something like this. How do we do that? By looking at our data structures, which is coming to us like here. So with that, let's jump into Power BI and see how can we shape the data from this structures into more of a data model defined. So let me close my Excel files so I can get more memory I can use, and let's jump into the Power BI. So first thing I'm going to do is we have seen this last time, but if you don't recall, this is a Power BI desktop, which allows us to create the data model and data cleansing and the data mashups we talked about. And by using the get data, we can connect to 115 plus sources I was talking about, right? It has a whole bunch of connections, but for purpose of our use case, our sales data and the dimension data is coming from Excel file. So I'm going to connect to the Excel as my source. I'm going to connect to my source file, the location of my file. And is it in what happened? This is interesting. Does not even read this file. Okay. All right. So I'm basically trying to load the Excel file that I just looked, which had very multiple tabs, and each of the tab has different information. So we saw a campaign dimension tab, which has campaign data. We saw a customer dimension, which had all the customer data. We saw a date dimension, which had all the date data, a geography dimension, product dimension, and the sales table that we had. So I'm just going to bring all of this information, and before I load, I want to transform it. So when I hit transform, it's going to open what we call it as Power BI query editor, query builder. So let's see. Once we load this data, this is what is called Power Query Editor, and here we have the sales data, all the data that came from the sales tab on that file. So I have all the product campaign and everything we have. Everything looks fine to me at this point. I'm just going to make sure that the date is at the date format. I'm going to come back to product in 1 second. Zip code. So last time also we saw that zip code by default, when Power BI reads Excel file, it sees all of them as a number. It makes a data type as number, whereas we all know that zip code is not really a number field. It's really a text field, because you can also have leading 0 and a number field, remove those leading 0 from it. So I'm just going to change the data type from number to text. And what it will do, ask me is, do you want to change the column type and you want to replace the current one or something? So I know as what I'm doing is I want to replace my values. So it's going to convert the data type to text. And as you can see, it is left indent because it is now text, not really a number. So that's all I want to do at this point of time. My date dimension should be fine. I don't have to change anything here. My customer dimension also has a zip code, which is going to be the joining key between the term. And again, this is a number field. I want to make sure it is also text. so it does not miss out any leading zeros. So I'm going to replace the value, and it is going to become the zip code also, the text field. So I think pretty much in campaign, I don't think I need to do anything. Everything looks fine to me. Product dimension. So if you recall, when we were looking at our data model, we need category and segment dimension, which is a snowflake of a product dimension. And if I look my Power BI query editor, the category and segment is part of the same. So I need to create a category segment dimension out of this. So first thing I will do is I will right click and I will say duplicate table. So what it will do is it will create a copy of the same table exactly as it is. So I'm just going to rename it. So because I'm going to generate a category segment dimension from this data. So this is first thing I do, and then I see I have category and segment here, but I also have product and everything. I do not need product and other product related attributes at this point because it's a category dimension. I'm going to highlight these two columns and right click and say remove other columns. So what it will do is all other columns are deleted. Again, mind you, in the product dimension, I have all the columns I need, but in category segment dimension that I just created, it only has a 2 columns. But here also you can see I have all these different categories are repeating for each of these segments. So I don't want this. So I'm going to highlight both of these columns again, and I will. So if I can highlight them, say right click and say remove duplicates. So what it will do is it will only keep one copy of each of this combination, and everything else is pretty much gone. So this is good. This is what it looks like, but I need to have an identity column. So what I can do is go to add column, and there's a feature called index column, and I can create index starting from 1. So what it will do is it will add a new column, and now it has given an identifier to each of these columns. This looks good. I'm just gonna change this column name to call it category segment ID. Everything looks good. I'm just gonna make it first column in my table, and now it's good. So I like it. I got my category segment dimension, and in product dimension, I also have category segment dimension. So ideally, if you recall, for our model to work, this product dimension should talk to the category segment dimension using the ID. So what I should do here is I need to make sure that I get the same IDs I created here into my product dimension. So how do I do that? I'm actually gonna come here and say I want to merge queries. So I'm in the product dimension and I'm trying to merge my product dimension with my newly created dimension called category segment. And now I can say, what is my merge column? So my merge column is the category and the segment column of product table, and category and the segment table. I highlight it, give the right order of the join. Left outer join is fine. I'm just gonna say okay. What it will do is it has created a merge, but it's an entire table. I do not want the entire table. I just want that column. So I'm gonna expand this. I do not want all the columns. I just want the category segment ID. And I do not want to have a column name prefix. So let's just do it. So what it will do is it is now showing me the category segment ID of these categories and segments that were here, right? So now I can safely go highlight these columns and I can remove it because I do not need it. I already got the ID which is coming from the other table. So I can say remove columns. So this looks pretty good to me. I can just reorder and make sure my category and segment come here. So I know my product ID, product name, category segment name, and actually these columns are also it is only data for one manufacturer. At this point of time, I do not have multiple, so there's no value of these columns. So I can safely delete this because it's not giving me any additional value. I want to keep my size of my tables as small as possible so that it does not consume memory. So this looks good to me now. I have product ID, I have product name, a category segment which it belongs to, and the cost. And using this category segment, I can join it to here, and I know which category and segment it belongs to. All right, I think this looks good. So now we have to bring the budget data also here. So the budget data is actually a CSV file. I'm gonna go and I'm gonna say, okay. Budget this forecast segment. So we're going to use this. Use this for see how about so first thing was from I can say only keep top 3 rows because I really need to manipulate all my data. So I only have my data of all the headers that I need to fix. Once I have it, I'm going to actually transpose this and make columns into rows. So what I can do is I can go and transform and hit the button transpose. The moment I do that, the data is now in this kind of a format. I have a column for forecast, and for each forecast, it is for each month and year. So this looks much better. Okay. So what do I do now? So I'm going to actually create a budget month because this is a kind of a text kind of a column. I'm going to create a new column, a custom column, which is basically a date kind of a format. By date from, I'm going to use M query expression here. And I'm going to say, I want to combine, and you can see I'm combining column 3, which is month, and ampersand is a combining the connector for joining 2 columns. I'm going to combine these 2 columns as date. It's going to try. If it does not meet, because you see this column 3 is a category and segment, we don't want it to become a date, give an error. That's why I'm using a try statement. So if it is not able to convert, then I'm going to say otherwise null. Okay, I do not see any syntax error, so this looks good. So I do it, I created a new column and it converted these month and year into a date kind of a format here. And this one, because it was category and segments, it gave us a null. So far looks good. Now what I need to do is I need to create, again, remember that we need to create something like scenario, month, and the category segment ID. So I still have a lot of work to do. What I'm thinking is I'm going to create one more custom column. And I'm going to use and say if column, and you can see the validator here, if the length of this column is more than 3 characters, which is category in these 2 rows. Basically, I'm trying to remove this from my thing. So I have to say if text dot length, this is interesting, text dot length of my column 3 is greater than 3, then I just want to keep it column 3. Else, I want to combine column 1 and join it with my column month and budget column. I want to combine this column with this is date. I want to change it to text of this custom column I just created in a format which is MMDDYYYY. Okay. And I don't see any error. So basically what I'm doing is I'm actually creating a new column which is combining column 1, which is a forecast or a budget, and the date, that this column in a format of month and year. But if it is not something which is of date format like these two rows, I want to leave it as column 3. So once I do this and I say okay, I will get something like a combination of forecast and this date, right? This is what I just created. This looks good. I think I like it, but now I think I still have to play with this data. So what I'm going to do is I'm going to actually remove all other columns and only keep this one column. Okay. And I'm going to actually transpose this rows back to the columns. Okay. So I got, if you see the category, I have now one column for category, one segment, and each of them is a forecast and a month and a year, which is actually, if you look at my original data, I had the same thing. I had a category and segment, and each of these value is actually nothing but a forecast, month and year, this formats. So if you see all the way down, I have the last one is for budget January 2015 and the numbers for each category and segment, and this is actually what I have here. If I go scroll down all the way out, I have the budget for January 2015, right? Exactly same thing. So I was able to get the columns in the order I originally have, but I still need the data, right? So I can do is I can append this formats I have created and bring the actual data of the column by appending this thing, because it's the same columns. It is able to quickly append the data of this table, which was this format, into my this thing. Okay. Now what I can do is this one is actually it should be my column name. I do not want column 1, 2, 3, 4. So I'm going to say use first row as header. It creates this, and now if you see this forecast 2016 December is same as forecast 2016 December. So I do not need these first 3 rows. So I can say and safely go and say remove top 3 rows. Quick time check, guys. We are almost done. So now I'm good. I have each of these things and it is looking good, but I still need them in a row format. I do not want this into column format. So I can do a transform one more time. And I'm going to say transform and transpose. And I got it here. Okay. And actually, this transform, we should have done it a little bit. I think we did it after appending. We were able to remove top 3 rows, and this column still gives me, I think I need to delete this step. Okay, so we were here. And before actually I transform and transpose, I need to actually unpivot this data, which is sitting here. So what I can do is unpivot these other columns. So this gives me the format I was looking for. That category, for each category I have, for each scenario, I have each date and month. So I can quickly go and split this column into multiple columns, which is very easy. We did it last week also. I'm just gonna do split by the delimiter that I added so that I can split this column. So now I have scenario. Let's see, ENAR scenario. And I have, this is my date column. And this is my budget amount. Okay. So now I can quickly change the data type of this column, make it this. It is already date. We just want to make sure it is a date column, and everything else looks good. So everything else looks good. I just have to remove this and get the ID from the category segment ID, which is very simple and easy. We just did it for other table. I'm just gonna do the same thing here. So I'm gonna say merge queries, and I'm going to merge to the category segment dimension. Same thing, I'm going to select the 2 joining columns from here and the 2 joining columns from here, leave it left outer join and say okay. It will add the same way, and I'm going to expand it. I do not want everything, I just want my category and segment, and say okay. So it gives me the category and segment, and now I do not need these 2 columns. And I'm going to remove these columns. Okay, and I'm going to bring this to front. So this is very much similar to what we saw originally. I'm just going to quickly rename this to budget fact. And at this time, I do not need to load this table. So I can click on this table and say, no, disable the load. So now if you see, my table is very much in line with what I originally thought I'm going to do. Everything is ready. I'm just going to say close and apply and load this data in Power BI. So what it is going to do is it is going to load the data in Power BI. It's basically now it is the Vertipack engine I was talking about. It is loading the data that we read from Excel file in memory of Power BI desktop using the compression from the Vertipack engine that is part of the Power BI solution. So it is reading all these Excel and CSV files and it's going to load it here. Okay, it's pretty much done. It's detecting the relationships and everything looks good. It has loaded the data. So you can see now we have all the tables that we saw. We can go to the data tab and start to see all the data that we have for each of these tables. So we have our budget data in the same format that we saw. We have our campaign data, the sales data, everything is coming up the way we wanted it to be. But most important thing that goes is, I think, goes back to our data model. So we have created the star schema, or the actually Snowflake schema in this case, which is needed, and we were able to recreate this data model that we originally thought of using for Power BI reporting. If you see, I have my sales table, which is Snowflake kind of a schema because customer is broken down by zip code, and I have my budget fact, and which is linked with my category dimension, and it is not linked with date. So date is one column which is not able to identify the relationships. But everything else, the relationship already came because of how we define the data model in the query editor. But it's very easy. I can just link this date with this date in the date column, and it will build this relationship right here. Right? It's one date for multiple sales, and I can do the same thing here. I'm going to link my date to date here, and it's going to define the relationship also right here. Interesting. Some reason it's not. Let's do it manually. I can go to manage relationship. I can go and say I want to create a new relationship. I want to have my budget fact linked with the date dimension, right? And interestingly, it is not able to define the cardinality, but yeah, using this, we will be able to complete our data model. All right. Okay. Perfect. Yep. So now that we have data model created, we can go ahead and start creating the reports that we need to bring, and that will go against customer dimension and budget and the sales. So that's all I wanted to show you today, that how we can use the various features and capabilities of the Power Query Editor that we have seen here to shape and transform the data, consolidate the data into data model using various features of mQuery that we saw. All the features that we were using from the different ribbons actually is a part of mQuery, and you can see when we do this, all the things, all this single step is recorded right here. So that's actually one of the beauty of Power BI. It's actually recording every single step. So if you make any mistake, you can just delete that step and do it over again. But the another beauty of that is every time you refresh the data, like we talked about last week, is you have to replicate your VLOOKUPs and everything else that you have built logic in Excel file You do not have to do that in Power BI because Power BI knows how to transform in each of these steps. So every time you refresh the data, load the new data, it will automatically apply all these steps and show you the final data model that we saw in the thing. And if you want to see the M query editor, you can see it everything. I did it using the UI. Actually, is a part of M language that you can, if you know how to write this, we can do it ourselves directly in here, and it will create the same steps right here. So with that, Sarah, I'm gonna pass over the control to you and see if there are any questions we can take from the audience. Sarah, you're able to hear me?
You guys hear me? All right. I think that's okay. So this one we're going to open questions. If you have any questions, there's a little chat box. Feel free to type the question into there, and I will read it out loud to Tarun so he can answer it.
Yeah, please feel free to send your questions through chat. Or if you want to actually also ask me at a later time, like last time also a few people asked, you can always feel free to email your questions to me. My email address is shown here, tarun@motiveworks.com. So, excuse me. Yeah, you can feel free to send me your questions later on if you want. But while you are having all your questions prepared, this was the second webinar in the series of 5 we did today to really ingest and consolidate data and really shape the data in Power BI. We have follow-up webinars coming up next week. The third webinar in the series is Tuesday at the same time next week, which is around creating complex transformation to build on top of the data model we have learned. So if you might have noticed that we have only the unit sales, but we do not have the sales amount or the cost amount and maybe a monthly sales. So there are multiple transformations we can do on top of the data model that we have built to create right metrics that we need to create reports. So that we are going to cover next week. And for in the following the webinar after that, we are going to see how can we use all the transformation consolidations and the data ingestion we have learned so far to build compelling visualizations to tell a story using data. Okay, and the last one in the series, we are going to talk about various artificial intelligence features in Power BI. And I've actually also written some articles and blogs on this on my LinkedIn profile. So you may want to, if you want to see what other features are available and some of those features pique your interest, you should join this webinar. So where we will actually demonstrate how do we really build artificial intelligence. So quickly to go over my link of my LinkedIn page, you can find me on LinkedIn at this URL.
And then just follow up for anyone interested in registering for the upcoming webinars, you will receive an email following this webinar in the next 24 hours containing a link where you can register for any or all of the upcoming webinars. So we definitely hope to see you guys there to sort of follow up on what you've learned today. And I am not seeing any questions, but as Tarun said, feel free to email any of your questions to him at the email shown on the screen, and he will get back to you and answer your questions for you.
Perfect. All right. Yep. So thanks everyone for your time. If there are no questions at this time, we will conclude today's webinar and hope it was useful and it was enlightening. And please join us again next week to learn about complex transformation that we can build on top of this.
All right. Thank you, everyone. Thank you, Tarun.
Sure, thank you.
We will see you next week, hopefully.